Okay. We will wait for the others also. Hi Sneha, hi Joshua. How are you? What happened to Joshua? Joshua, is there any network problems? Any network issues? Are you getting good network connection? Can you hear me properly? Joshua, can you hear me properly?
Yes, sir. Yes, sir.
Okay, good. Okay, we can continue our session, right? We can continue to do solving this worksheet. Just look at question number 14. Did we do question number 14? We have done question number 14, right? We have done question number 14, right? Who is this Gogol? Is that Gautam? Gautam? Yeah, it's Gautam. Okay. And question number 50. Question number 50. Please write question number 50. Make it a little bit faster. Question number 50. Question number 50. Or give some space for that question. Give some space to write that question. Okay? Give some space to write that question. We are discussing question number 50. Read it. The displacement time graph for two particles A and B are straight lines, right? Straight lines making angles of respectively 30° and 45° with the time axis. With the time axis. What is the ratio of the velocities of A is to B? Or what is the ratio of velocity? What is the ratio of velocities? That is the question. What is the ratio of velocities is the question. What is this? This is a displacement time graph. What is this? This is a displacement time graph in the question. Displacement time graph in the question. So where will be the displacement? Where will be the displacement? We are doing question. We are doing worksheet of first worksheet of this chapter 2. And we are doing question number 50. Question number 50. Give a little space to write that question and we will discuss the answer. Solution. Okay. Give a little time to Shika. Shika, just wait here. Okay. Okay, Shika, are you ready? Do you have this worksheet with you? You bring the worksheet. If you don't have the worksheet, you can look at the phone. Oh, that's the worksheet, right? That's previous worksheet. Oh, sideline. The worksheet from sideline. Do you have the worksheet from sideline? You have that, right? You can look at the phone. Look at the phone. Take the phone, and there will be also PDF in it. There will be PDF in it. And we are discussing question number 50. Question number 50. Question number 50. If you don't have the PDF with you, should I resend it? Here's what you do. Why is that? Just contact me after the session. Okay? Give me a message after the session. Oh. Hi, Jaden. Hi, Gautam, Joshua, Sneha. And we are doing question number 15. Can I do it? Huh? Are you ready? All of you? Okay, question number 15. The displacement time graph of two particles A and B are straight lines. So they are talking about a displacement time graph. So I am taking displacement here and a time here. Is that okay? Displacement time graph. displacement here, time here. This is displacement time graph, position time graph. Okay. Then A and B, they are two particles. A and B are two particles. They are making angles with the time axis, and that angles are 30 degree and 45 degree. That is, A is making 30 degree with the time axis. Can you understand the question? A is making 30 degree with the time axis. This is A. A is making 30 degree with the time axis. This is the time axis. Huh? And B is making 45 degree with the time axis. B is making 45 degree. B is making 45 degree with the time axis. A is making 30 degree with the time axis, and B is making 45 degree with the time axis. From where did I got the idea? From where did I got the data? Yeah, from the question, it is saying that the displacement time graph for two particles A and B. You have two particles A and B are straight lines. They are straight lines making angles respectively 30 degree and 45 degree. Means A is making 30 degree, B is making 45 degree. Got it? Okay. With the time axis. What is the time axis? Time axis is this. Right? And what is the ratio of the velocities of A and B? What is the ratio of velocities of A and B? What is the ratio of velocities of A and B? VA divided by VB. This is what you have to find from the question. VA by VB is what from the question. That's the question. So the first problem is to identify the question. I will repeat the question for Sana. Sana, this is a displacement time graph from the question. They have given that two particles are there, A and B, and they are having they are straight lines, right? The velocity displacement time graph of both A and B are straight lines, and A is making 30 degree angle with the time axis, and B is making 45 degree angle with the time axis. That's in the question, and they are asked this VA by VB or ratio of velocities of A and B. You have to find ratio of velocities of A and B. That is VA by VB. How can we find VA by VB? This is displacement time graph, right? Okay, this is displacement time graph. You have to remember something. What is the slope of displacement time graph? What is the slope of displacement time graph? No, that's tan theta. What is
Velocity.
it? Slope of displacement time graph. X
Velocity.
by t. What is x by t? X by t. Displacement time graph. Slope of displacement time graph will be y by x, right? What is y? Y is delta x divided by what is x? X is delta t, right? So delta x by delta t is slope. Who is this delta x by delta t? Displacement by time. Who is that? Yeah, velocity. So slope of displacement time graph will give you velocity. Slope of displacement time graph will give you velocity. You will get velocity from the slope. Okay, you will get velocity from the slope. And slope has another equation also. Slope has another equation. What is slope? If theta is given, what is slope? Tan theta. If theta is given, the slope will be tan theta, because tan theta is opposite side by adjacent side. That is y by x. Tan theta is opposite side by adjacent side. That is y by x. That is slope. So if you want to find slope, you can find tan theta. Tan theta will be slope. We have this equation. Slope will be tan theta. Got it? Slope will be tan theta. Now, if you want to find the velocity of A, VA, what will be the value of VA? Velocity of A, slope of A. Velocity of A, that is slope of A. Velocity of A is slope of A. Right? Velocity of A will be slope of A. How can you find slope of A? A is having this angle, 30 degree. 30 degree. So tan 30 will be the value of velocity of A. What is tan 30? 1 by root 3. You have to remember it. Tan 30 will be 1 by root 3. Okay. So tan 30 is 1 by root 3. 1 by root 3. That's the value of VA. Got it? Now, what will be the value of VB? Help me. What will be the value of VB?
1.
Yeah, VB will be slope of B, right? Slope of B. Slope of B. Velocity of B will be slope of B. Okay? What will be slope of B if theta is given? If theta is given, slope of B will be what?
1.
Tan of an angle, right? Tan of that angle. Tan of that angle, right? So tan B is having this angle 45 degree. So tan 45. What is tan 45? What is tan 45?
It's 1.
Yeah. So 30 degree and 45 degree. Tan 45 has a value 1. We know that. Right? It is having a value 1. We know that. And what you need, VA by VB. You need VA by VB. We need VA by VB. What is VA by VB now? VA is 1 by root 3. 1 by root 3 divided by, what is VB? VB is just 1. VB is just 1. Do you get it? What is it, Gautam? So that's our question number 15. Can we look at question number 16 now? Question number 16. Question number 16. Give some space to write question number 16. Give some space to write question number 16, or you can write it now. You can write it now. Question number 16. It's a small question. A small question. Velocity time graph of two objects make angle 30 degree and 60 degree with the time axis. Find the ratio of their acceleration. You are to find the ratio of their acceleration. Okay. Did you write that question? Did you write that question? Can we try to do that question? Question number 16. Read it. What is that? Velocity time graph. Now we need velocity time graph. So I will draw a velocity time graph here. This is a velocity time graph now. I have a velocity time graph. And which are the particles? Two objects. They didn't say it is A or B, right? Two particles. So I am taking the first one like this. I am calling it as A. I am calling it as A. And I am taking the second one like this. I am calling it as B. Okay? I am calling it as B. And what is the angle of their angle is 30 degree and 60 degree. Their angle is 30 degree. So the angle of A is 30 degree. A is making 30 degree with the time axis. Okay? And B is making 60 degree. B is making 60 degree with the time axis. I just Just called it as A and B. It is not given in the question. I just called it as A and B. Okay? Okay. Then what is it? What is it? What is the find the ratio of their acceleration? What is the ratio of their acceleration? That is the question. What is the ratio of their acceleration is the question. What will be slope here? What will be slope here? Huh? What will be slope here? Slope is y by x, right? Or tan theta. What is y here? Y here will be a velocity change. Y here will be a velocity change. That means at this point you will get a value of velocity here. At this point you have already have a velocity, that is 0. So you have a velocity change here, right? So y is velocity change. Y is velocity change divided by what is x? X is time. X is time. So velocity change by time. What is that? Acceleration. That's acceleration. So slope of velocity time graph will be what? That's acceleration. Slope of velocity time graph will give you acceleration. Did you understand that? That will give you acceleration. So you need the ratio of accelerations. Ratio of accelerations. That means acceleration of A will be what? Acceleration of A will be slope of A. It will be equal to slope of A. It will be equal to slope of A. Acceleration of A will be equal to slope of A. Okay. So acceleration of A is equal to slope of A. How can you find slope? Slope has another equation. Slope has another equation. What is the next equation for slope? Tan theta. What is slope? Slope is tan theta. What is slope? That's tan theta. So I am writing tan. What is theta for A? That's 30 degree, tan 30. Okay, that's tan 30. Okay, what is the value? What is the value of tan 30? Yeah, 1 by root 3. So that will be 1 by root 3. 1 by root 3. Okay, now I need AB. What is AB? Acceleration of B. Acceleration of B will be slope of B. Acceleration of B will be slope of B. How can you find slope of B? I can use this equation tan of angle of B. What is the angle of B? Angle of B is 60. Angle of B is 60. So tan 60. Tan 60. What is the value of tan 60? Huh? Yeah, root 3. Tan 60 will be root 3. Tan 60 will be root 3. Now I have AA and AB. I have AA and AB. I can take the ratios. I can take the ratio between A and B. I can take the ratio between A and B. We have allergies, no? Should be off that. And ratio between acceleration of A and acceleration of B. What is that? AA by AB. AA by AB. What is that? 1 by root 3. 1 by root 3 divided by root 3. That will be 1 by root 3. 1 by root 3. Take the reciprocal and multiply. If you are taking the reciprocal of root 3 by 1, that will be 1 by root 3 again. So 1 by root 3 into 1 by root 3. 1 by root 3 by 1 by root 3 by root 3 will be what? 1 by root 3 into root 3. Did you understand that? No? Just like this. 1 by root 3 into, take the reciprocal of it. What is this? Root 3 by 1. Reciprocal of it will be 1 by root 3. So 1 by root 3 into 1 by root 3. That's 1 by root 3 into root 3. Okay? That's 1 by root 3 into root 3. If you are multiplying root 3 into root 3, what you will get? You will get 3. Root 3 into root 3 will be 3. 1 by 3. Like this. Root x into root x will be what? That's x. Square root of x into square root of x will be just x. Like that, you can write root 3 into root 3 will be just 3. Root 3 into root 3 will be just 3. Root 2 into root 2 will be 2. Root a into root a will be a. Like that. So we have the ratio of accelerations. The ratio of accelerations are AA by AB. AA by AB. That's 1 by 3. AA by AB, that's 1 by 3. Got it? AA by AB, that is 1 by 3. Okay? Can we move to the next one? Did you complete that? Navira? Is it complete? Gautam, Jaden, Joshua, Sneha? Are you finished? Can we move to the next one?
Yes, sir.
Okay, good.
Yes.
Good. Then look at the next question, 17th one. 17th question. Question number 17. Question number 17. Look at question number 17. The acceleration time graph of a particle in rectilinear motion is given in the graph. Find the average acceleration in the first 30 seconds. That's the question. Find the average acceleration in the first 30 seconds. In the first 30 seconds, that is the question. Okay. So draw that figure. Draw that figure. What is that? That is an acceleration time graph, right? That's an acceleration time graph. So acceleration is in y-axis, time is in x-axis. That's an acceleration time graph. Just draw the graph. Draw the graph. It is like this. The graph is like this. The graph is like this. Okay? And the values, what are the values? Here you have A, here you have B, and it is at a point 20 meter per second square. That's the unit of acceleration. And there is a 10, I am not marking that 10. And there is A, which is equal to this 10 seconds. A is equal to 10 seconds. Or A can be projected to 10 seconds. And like that, B can be projected to what? B can be projected to 20 seconds. And there is 30 seconds also. There is 30 seconds also. Time is in seconds. Time is in seconds. Okay. Find the average acceleration in the first 30 seconds. That is the question. Find the average acceleration in the first 30 seconds is the question. Okay. I will just explain that idea with this rectangle. With this rectangle. Okay? Just consider this rectangle. Just consider this rectangle. Can you see a rectangle here? A, B, C, D. I am naming it A, B, C, D. Can you see this rectangle? Okay. Now I am taking the area of that rectangle. The area of rectangle. What will be the area of the rectangle? Length into breadth. That's the area of the rectangle. And here length is what? That's a time. I am not taking the values. I'm just taking what the quantity is. What is that quantity? Here length is time, right? Into what is that? What is the breadth? Breadth is acceleration. A. Length is time, right? This will be a time. And this will be an acceleration. This is a time and this value will be an acceleration. So the length will be time, the breadth will be acceleration. Did you get it? Length will be time, breadth will be acceleration. Can you understand that? Okay, so time into acceleration is area. Time into acceleration is area. Did you understand that? Time into acceleration is area. And what are they asking for us to do? Find the average acceleration. Find the average acceleration. How can you find acceleration from this idea? Area is time into A. So what will be A? Yes, A will be area divided by time. That's the idea. That is the idea. So if you find the area which is corresponding to 30 seconds, you will get area in 30 seconds. Okay, and time is 30 seconds. If you divide that, you will get acceleration. Okay, so I am just finding the area. How can I find area? How can I find area up to 30 seconds? This is the point 30 seconds, right? That's the point 30 seconds. So I am finding the area. Or should we write it? Yeah, we can write it. Area under acceleration time graph. Area under acceleration time graph divided by time. Area under acceleration time graph divided by time will give you what? Will give you acceleration. Will give you average acceleration. Did you understand that? Area under acceleration time graph divided by time will give you acceleration. Okay? So I am going to find area. Under acceleration time graph up to this 30 seconds. Okay? So area up to 30 seconds. Area up to 30 seconds. What is that? Area of this OAC. That will be area of this triangle OAC. You can see a triangle here, right? You can see a triangle here. You have to add the area of this triangle plus you can see a rectangle here. You have to add the area of the rectangle also. Right? You have to add the area of the rectangle also. So area of rectangle. What is that? ABDC. ABDC plus. Now area of triangle DB. I am taking it as E. DBE. So the third term is area of triangle. What is that? DBE. DBE. Okay? DBE. Okay. Now, what is this area? Area of triangle OAC. How can we find the area of a triangle? Yes. The equation for area of a triangle is half BH. Half BH. Half BH. Half B. B is base. What is base here? 0 to 10. What is base? Look here. What is the base? 0 to 10. What is the base? 10.
10.
That's 0 to 10 means 10. So half BH. 10 into H. What is H?
20.
Yeah,
20.
H is the vertical. H is the height or C to A. C to A is 20. So 20. That's our first area. Got it? That's our first area. Plus, now you need area of a rectangle. How can you find area of rectangle? Just length into breadth. That will be length into breadth. What is the length?
20 into 10.
That is CD.
20 into 10.
Yeah, CD. CD will be 20 minus 10. What is that? 10. So the length will be 10 into what is dB? dB is 20. So 10 into 20 will be the area of rectangle ABDC. Rectangle ABDC. Plus, now you have a triangle DBE. How can you find the area of the triangle? Half BH. Half BH. Half B. B is the base. B base is what? 30 minus 20. What is that? What is the length from this point to this point? 20, 30. Between them, there will be 10. So 10 into height. What is the height of the triangle? D to B. D to B is 20. Right? So that will be 20 again. Okay? Find this. Find this. How can you find this? Yeah, how can you find this? This 10. This 10 can be cut with this 2. You will be having this 5. 5 into 20 will be 100 plus 10 into 20. 10 into 20. What is that? 10 into 20. That will be 200 plus this 10 and 2 can be cut with 5. So 5 into 20. Again, what is that? That is 100 again. So 100 plus 200. What is that? 300. 300 plus 100. What is that? 400. Now, what is area? 400. Area is 400. We have area now. We have area now. What do you need to find? You have to find acceleration. Acceleration. How can you find acceleration? How can you find acceleration? Yeah, area divided by total time will give you acceleration. Okay, what is total time? Time 30. Time is 30 seconds. Time is 30 seconds. If it is asked for 20, what will be that? You can take it as you can take the area up to 20 and divide it with the 20. Okay, so 30 seconds is the time. And area is what? Area is 400 divided by 30. 400 divided by 30. 40 by 3. What is that? Is that 13.3? Okay. 13.3, that's acceleration, meter per second square. Okay, that's acceleration. 13.3 meter per second square. You got the acceleration. How did you go the acceleration? This is the idea. This is the idea. What is the idea? Area under acceleration time graph is acceleration. Sorry, area under acceleration time graph divided by time is acceleration. Okay? So that way you can find the acceleration from the graph. Which graph? Acceleration time graph. If it is a velocity time graph, what will be acceleration? If it is a velocity time graph, what will be acceleration? Acceleration will be the slope of that graph. Acceleration will be the slope of that graph. Slope of that graph will give you acceleration. Did you get it? Okay, can I move to the next one? Okay. Then the next question. 18th question, right? 18th question. 18th question. I am doing 18th question. The position time graph for two children A and B returning from their school O. Okay, so there is a graph there. I will draw that graph here. This is our graph, and this is X for position. This is time T, and two students A and B. A is traveling like this. A is displaced like this, and now B. B is starting from this point, and B has displaced like this. Okay, B has displaced like this, and both of them are at the same point like this. Okay, and the point here is Q. The point here is Q. Draw that graph in your notebook. The point here is what? That's Q. And the point that is corresponding to the next one. The point corresponding to the next one is P. The point corresponding to the next one is P. And this is A. This is B. This is the graph. Draw the graph first, and then there is some questions. You have to identify what are the answers. How to get what are the answers. This is the question. This is the graph from the question. So first draw the graph. draw the graph from the question. Draw the graph from the question. Once you have drawn that, let me know. I will explain the questions one by one. I will explain the questions one by one. You have given some space to write that question, right? You should give some space to write that question. You should write the question. An answer without a question has no meaning. So there must be a question every time you are doing a solution in your notebook. Okay? Okay, then we are checking one by one. We are checking the questions one by one. First, question number A. Question number A. It is saying that A or B lives closer to the school than B or A or A or B. What is that? It can be A lives closer to the school than B or B lives closer to school than A. Which is the correct option? That is the question. Which is the correct option is the question. Who is closer to school? Which is school? Which point is school? Point O is school. Point O is school. Which are the homes of them? P and Q are the homes of them. It is given to their homes P and Q respectively. That means home of A is P. That's home of A. Right? And home of B is Q. That's home of B is Q. Got it? Okay. Now tell me who is near to school. Who is near to school? Yes. Who is near to school? This is what at this point or at this line, that's actually y-axis, and in y-axis you have displacement. So this is displacement from the school. Who has greater displacement from the school? B has greater displacement from the school, right? This is B. B has greater displacement from the school. A has lesser displacement from the school. That means A is closer to school. Did you get it? A is closer to school. So what is our answer? A lives closer to the school than B. That's our answer. A lives closer to the school. A lives closer to the school than B. Got it? A lives closer to the school than B. That's the first one. And let us check the second one. What is the second one? A or B walks faster than B or A. Who walks faster? That is the question. Who walks faster is the question. Who walks faster is the question. A has started from a point. A has started from school. That's point O. And B has also started from school, but B is a little late. A is early. A has started from school early. A has started from school from 4 o'clock itself. B hasn't started from 4 o'clock. We waited a little to see someone. Maybe we don't know that. Okay, there is that. So we have waited a little bit of time, So we have started late. But they both reached home at the same time. Right? This is the time they have reached their homes. A is reached at home at time T. B has reached his home, which is very far compared to A. But even then, he reached his home at the same time. That means he must have walked faster. Then only he will be reaching at that time, at the same time as that of the A, right? So, what is that option? B walks faster than A. B walks faster than A. B walks faster than A. Did you get it? B walks faster than A. Everyone, did you understand that? Okay, then third one. Look at the third one. C. A or B start from the school earlier than B or A. That's so evident, right? A has started from the school earlier. B has started late. So what is the question? Starts from the school earlier. Who is starting from the school earlier? A is starting from the school earlier. So you can write it like this. A starts from from the school earlier. From the school earlier than B. Earlier than B. That's the answer. Then look at question number D. Look at question number D. What is question number D? A and B reach home at the same time or different times? Yes, they are reaching their home at the same time. So A and B. A and B are reaching. A and B are reaching home at the same time. At the same time. At the same time. They are reaching the home at the same time. Did you get it? They both are reaching the home, their respective homes at the same time, at a time T. Got it? Okay, then that's D. That's option D. Now look at option E, our last option. What is option E? A or B overtakes B or A on the road twice or once. Once or twice. Who overtakes who?
B over D.
Yes, B is the one who started late. B is the one who started late, even though B is overtaking A once, right? Only once. This is the intersection point. Intersection point is showing the overtaking of B of A, right? B is overtaking A on the road once, right? So that's the last one. B overtakes A. B overtakes A on the road. How many times? How many times?
One.
Just once. Once. Got it? So that's it. Okay? Huh? We have some more questions.
Sir, next class.
Are you bored with the questions?
No, I just.
Another chapter.
I know these hundred.
Yeah, we just started it a little bit. And that chapter, we have to study something about some quantities, some amount to study in that chapter. But this chapter is also important. It is actually simple also.
Yeah, so let's do the other chapter.
But when you will do this one?
Class.
Next class.
Yeah, I have a test tomorrow morning.
Third chapters. Huh? In which way? Next.
Third chapter, seven.
Okay. Then we will try to do an extra session on this worksheet to do the calculations. Okay? 13th. 13th. Okay. Then where are we on the third chapter? Where are we on the third chapter? We will do the rest of the questions later. And just look at third chapter. Have we completed the types of vectors? Have we completed types of vectors? Did we write negative of a vector? No. What about equal vectors? Did we done with the equal vectors? Are we done with the equal vectors? same direction. They are equal vectors. So we are discussing types of vectors. Just look at it. Types of vectors. First one. What was that? First one. First one was no. Types of vectors. Equal vectors. Types of vectors. The first one was equal vectors. Equal vectors. We studied what is equal vectors, and after that, the second one. What is second one? Negative of a vector. The second one is negative of a vector. Negative of a vector. Negative of a vector. Write with me. Negative of a vector. I will show what is negative of a vector. I will show what is negative of a vector. This is a vector. I am taking it as vector A. I am taking it as vector A. And if there is another vector having the same magnitude, another vector having the same magnitude but opposite direction, then that will be negative of vector A. That will be negative of vector A. So what is negative of vector A? Negative of a vector is what? Another vector having same magnitude but opposite direction. Just write it. Another vector having equal magnitude but opposite direction. Another vector having equal magnitude but opposite direction. Another vector having equal magnitude but opposite direction. Okay? Okay? Okay, then the third one. Third one is modulus of a vector. Modulus of a vector. That's not a type of vector, but you need to understand this term. Modulus of a vector. Okay? Modulus of a vector. Look here, we can represent a vector like this. This is the representation of a vector. This is the representation of a vector. And what is modulus of a vector? Modulus of a vector can be represented like this. This is modulus of a vector. Don't write it now. Don't write it now. Just look here. This is modulus of a vector. What is modulus of a vector? The magnitude of that vector. The value of that vector. If we are talking about force, I will just give you one example. I have applied a force of 10 Newton on this chair. I have pulled the chair towards me with a 10 Newton. Did you understand that? Then what will be the magnitude of that vector? Just 10 Newton. That's the magnitude of that vector without the direction. Without the idea of direction or the value only represented there, that's the magnitude. That's the value of the vector. That is modulus of vector. Modulus of vector can be written like this. This is modulus of a vector. Got it? That's modulus of a vector. Write it. Modulus of a vector. What is that? Magnitude of a vector. Magnitude of a vector. That's modulus of a vector. Magnitude of a vector. Magnitude of a vector. That's modulus of a vector. Okay? Magnitude of a vector. And it's a scalar quantity. As you can see, this is a scalar quantity. No direction in it. So, it's a scalar quantity. Can be expected in an MCQ. It's a scalar quantity. Scalar quantity. It's a scalar quantity. Got it? So that's modulus of a vector. Then we are talking about the next one. Unit vector. Talking about the next one, that will be unit vector. Unit vector. We are talking about the unit vector. Okay? Now look here. I am drawing the axis. This is the origin. You have x-axis, y-axis, and z-axis here. Just like a corner. Just look at a corner. You can see x-axis there, y-axis there, and also z-axis. At a corner, you can see x, y, and z-axis. And there is a vector that is showing the direction of x-axis. There is another vector that is showing the direction of y-axis. Also, there is another vector which is showing the direction of z-axis. Okay? And I can take that vectors as the vector which is showing the direction of x-axis is I cap. What is that? I cap. The vector in the direction of y-axis is j cap. The vector in the direction of z direction is k cap. These are called unit vectors. Unit vectors. They are having unit magnitude. They are having unit magnitude but a particular direction. They are having unit magnitude but a particular direction. They will have a direction but magnitude will be just one. Okay? Just write it. Just write it. Vector having a unit magnitude. Vector having a unit magnitude and a particular direction. Vector having a unit magnitude and a particular direction. Vector having a unit magnitude and a particular direction. Unit magnitude and particular direction. You got it? And draw this figure. Draw this figure. This is showing I, J, and K cap. They are the unit vectors in the direction of X, Y, and Z. Do we need to write it? Unit directions in the direction of X, Y, and Z? No idea. Okay, draw this diagram, draw this figure. How can you find this value of vector, unit vector? How can you find unit vector? You can find unit vector like this. A cap will be vector A divided by magnitude of vector A. Right? Vector A divided by magnitude of vector A will give you a unit vector in the direction of vector A. What is that? What is that? What is that? Vector A divided by magnitude of vector A will give you a unit vector in the direction of vector A. Right? This is vector A. Vector A has a direction. Divided by magnitude of vector A. What will happen there? This magnitude is gone. Magnitude is gone. Magnitude is now just 1. And now you are with only a direction. That's unit vector. That is unit vector. You got it? That is unit vector. So you can find the value of unit vector with this equation. That's A cap is equal to vector A divided by magnitude of vector A. Vector A divided by magnitude of vector A. Okay? Okay. Now the unit vector has no units or dimension. What is unit vector? It's just a direction. Okay? That means it does not have a unit. It does not have a dimension. So you can add that unit vectors has no unit or dimension. Unit vectors has no units or dimension. Unit vectors has no units or dimension. No units or dimension. Does not have any unit. It does not have any dimension. You got it? Huh? That's about the unit vectors. And then fixed vectors. There is fixed vectors. What is fixed vector? I'll show that here. Fixed vector. Write it. Fixed vector. Fixed vector. Fixed vector means its initial point is fixed. You cannot move it. Right? Don't draw it. Its initial point will be fixed. That's fixed vector. You cannot displace it. You cannot displace it from anywhere, from that point to anywhere. That's fixed vector. Right? Fixed vector. Vector whose initial point is fixed. Vector whose initial point is fixed. Vector whose initial point is fixed. Can you give me any example for that? Can you give me any example for that? For fixed vector? Can you give me any example for fixed vector? Initial point is fixed. You have a clock. That's not vector. That's not vector. Vector means it should have a direction. What about a position vector? If you have a point here, if you have a point P here, this line from the origin is the position vector, and position vector cannot be displaced to any other point. The tail end of the position vector is fixed. So it can be called a fixed vector. So write that example. Position vector of a particle. Position vector, it's a fixed vector. Position vector, it's a fixed vector. Okay? Fixed vector. Position vector is a fixed vector. Now, the fifth one. Free vector. Fifth one is free vector. What will be free vector? Can you guess what will be free vector? Initial point is not fixed. That's 6. 1, 2, 3, 4.
Four again. Fixed vector. So unit vector was 4.
Unit 2 times. Unit 4 twice. Unit vector.
Oh yeah. Fixed vector, then free vector. That will be 5, right?
No,
Is
sir.
it? Sir, 1, 2, 3, 4.
1, 2, 3.
4.
Unit vector is 4 and it is 5. Now this is 6. Okay, that's 6. Free vector. What will be free vector? Carry girls. What will be free vector? Initial point is not fixed. Then that's free vector. Just write it. Initial point. Vector whose initial point is not fixed. Initial point is not fixed. That will be what? Free vector. Example, velocity vector. You can displace velocity vector to another point. That's example. Velocity vector. Velocity vector will be an example. Velocity vector. You can displace velocity vector. You can take velocity vector and displace that to some other point. Okay, collinear vector. Next one. 7th one, collinear vector. What will be collinear vector? Collinear vector. That is vector on the same line. Okay, that's collinear vector. I will show that. Now this is collinear vector. Vector A and vector B are collinear vector. Don't write it. Also, vector A and this vector B is collinear because they are parallel. And in the parallel, there may be two cases. This is parallel, like parallel. They are like parallel. What are they? They are like parallel. And if B is in opposite direction, they are unlike parallel. Okay? Unlike parallel. The angle between A and B is now 0 degree. If they are parallel, angle between A and B is 0 degree. Okay? And if they are anti-parallel, angle between A and B is 180. Parallel means they are in the same direction, like this. Right? Anti-parallel means they are in the opposite direction. From this to this will be 180. Okay? So this will be 0 degree and this is 180 degree. You will be needing these ideas in the numericals. Okay? Okay. Then write collinear vectors. Vectors acting along the same line. Vectors acting along the same line. Or along parallel lines. You can draw the figures. Or along parallel lines. Here theta is 0. Here theta is 180. You can draw the figures. Okay? Draw the figures. Yeah. Done? Then the next vector. Next type of vector. Coplanar vectors. What are they? Coplanar vectors. Co means common. Planar, plane. So common plane vectors. Vectors which are lying on the same plane. Simple. Vectors which are lying in the same plane. Vectors acting in the same plane. Vectors which are acting in the same plane. Vectors acting in the same plane. Got it? Vectors acting in the same plane, and these all are coplanar vectors because they all are acting in the same plane. They are coplanar vectors. If there is a vector A here, and imagine this as a vector. Imagine this as a vector, this pen as a vector, and it is acting like this. This is acting like this. Now this is in another plane. This is in this plane. This is in another plane like this now. Yeah. So they are not coplanar. If they are acting in the same plane, then they will be coplanar vectors. Write it. Vectors acting in the same plane. Okay. Then there is co-initial vector and co-terminus vector. You don't have to write it. What will be co-initial vectors? Co-initial vectors, vectors starting from the same point. Did you study that in school? So then write it. Then write it. Co-initial vectors. Co-initial vectors. Co-initial vectors. Co-initial vectors, right? Co-initial vectors. Vectors which have same initial point. Vectors which have same initial point. They are co-initial vectors. And the next one, co-terminus vectors. Yes. Co-terminus vectors. Vectors which have a common terminal point, a common ending point. Vectors which have 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 a common ending point. This is vector A and this is vector B. They are having a common ending point. Got it? Huh? Okay. After that, we have to see one important vector. That's 11th one, zero vector. Zero vector. Or it has another name. Just another name, that's null vector. It has another name, null vector. What is the another name for zero vector? That's null vector. Previous slide. Okay. Co-terminus vectors. They are ending at a common point. They are ending at the same point. If you haven't completed writing, then just ask me. I will not go speedy. Okay? You can just tell me. Is it complete now? Okay, then zero vector. What will be zero vector? No, null vector. Yeah. No.
The vector is here magnitude.
Having any value. It's not having any value. That means acceleration. I will show you one example. I will show you one example. If you have thrown a ball vertically upwards, with a velocity u, initial velocity u, and the ball has reached at the maximum point at this point. Okay, at that maximum point, velocity will be 0, and you know velocity is a vector, so that will be 0 meter per second. That means the velocity is 0. That's the zero vector. Okay, so you can write it. Vector having zero magnitude. Vector having zero magnitude. And a random direction. Or an arbitrary direction. You can write it like this, arbitrary. Arbitrary means random choice. It is based on the random choice. That's the meaning of arbitrary. This word is modern. This word you will be seeing this word in many places. So you have to learn this one. Arbitrary. Arbitrary direction. That's a direction of your choice. That's it. Random choice. Based on random choice. If I am choosing the direction like this, the zero vector is in this direction. If I am choosing the direction in this direction, that will be changed. Okay. So after that, yeah. Ask it. Okay. Totally forgot about that. We have to take a break. That's that. Our this section is complete. Types of vectors is complete, so you can take a break.
So we didn't take half of it. We took equal, zero, and negative.
Yeah, half of the
It's only three vectors. After three, 11.
Then you should do something. Just study that three only. Okay. Just mark them and study them. But all the others, you will need that somewhere in physics. Okay. You may need that. So don't study that for exam. Don't overstudy.
Yeah.
Okay. You can take a little break, a 10-minute break. This is 7:40 now. We will start at a 7:50. We will continue our session at 7:50. You all of you can take a break. Gautam, Jaden, Joshua, Sneha, all of you can take a break and we will meet at 7:50. Thank you. Welcome back, guys. Are you there? Kaudam, Jaden, Joshua, Sneha, are you there?
Yes, sir.
Yeah. But our offline students is not here. I cannot find them. I was about to call you, but I got confused with which number.
Why?
I have your numbers with 3 names on it. Everyone knows it. Maybe mom's number and the dad's number, your number. I got confused with which number. If I call your dad and okay. Now we are at zero vector, right? We have completed what is zero vector, right? Then write an example for that. Write an example for zero vector. The velocity vector of a stationary object. The velocity vector of a stationary object. That's the example for zero vector. This is a stationary object, right? That's a stationary object. And the velocity vector of a stationary object will be 0. What is the velocity of a stationary object? That's 0. And velocity is a vector, so 0, 0 vector. That will be a 0 vector. That will be a 0 vector. Got it? Okay. Now I have to discuss with you the next idea. We are done with the type of vectors. Okay? And I have to show you multiplication of a vector. Multiplication of a vector with a number. With a number. Multiplication of a vector with a number. There is no need of any notes. I will show that with a figure. This is vector A. This is vector A. Now I am taking the symbol lambda as a real number. What is lambda? Lambda is a real number. It can be 1, 2, 3, 4, 1.5, 1.3, anything. So lambda is a real number. What is lambda? That's a real number. Lambda is a real number. Got it? Lambda is a real number. And I am multiplying this lambda with the vector A. What will happen? What will happen? Its direction will not change. Its direction will not change. There is no change to its direction. Its direction will not change, but its magnitude has changed now. Its magnitude has changed now. Its magnitude has become lambda times A. Its magnitude has become lambda times A. The magnitude will be here, like this. So now the vector is this, lambda A. The vector will be lambda A. Nothing. I will just take this lambda as 2. I will just take lambda as 2. What is happening here? 2 into vector A. 2 into vector A. 2 into vector A. Vector A means double of this vector. Right? It will be double of the vector. Double of the vector. It will be double of the vector. Now it will be 2. You can write it like this. You can write it like this. Don't include lambda. Just write it with 2. You will understand that. Now the most important part in it, that's addition of vectors. Did you study that in school? Addition of vectors. We can add vectors. That's very important. That's very important if you are studying physics. Very important topic. Addition of vectors. I will write here. I will write it here. Addition of vectors. Addition of vectors. Okay? Addition of vectors. Okay? Here we need to see a word. We need to see a word. That word is resultant. Resultant. What is that word? Resultant. What is the resultant? The resultant is the result of addition of the vectors. If you have two vectors, like this, you have two vectors. I'll use simpler vectors. You have two vectors like this, 2 Newton and 3 Newton. 2 Newton and 3 Newton, they are acting in the same direction. And both of them are acting on a block like this. 2 Newton and 3 Newton are acting on the same block like this. Okay, so that will be equal to a 5 Newton acting on the same block. So now this 5 Newton is the resultant. That 5 Newton is what? That 5 Newton is the resultant. So what is resultant? Result of the addition of the vectors. Or it is a single vector that can produce the combined effect of the original vectors. That's a single vector which can produce the combined effect of the given vectors. That's the resultant of the vector. Did you get it? Okay, you can write it. Resultant of a vector. Sorry. Resultant. Just result. Okay. Write it. A single vector which can produce the combined effect of the given vectors. Combined effect of the given vectors. You can draw the example that is given in the board. It is given in the board, which is given in the board. This is a resultant now. This is result. You can draw that example. Got it? Are you finished? Namira? Chika? Then I want to show you laws of vector addition. What is the next topic? Laws of vector addition. What is this laws of vector addition? How to find a resultant? You can use laws of vector addition. I will take some examples and I will explain that to you. You have a ball like this, and you are applying a force A on this ball, right? Okay, and you are applying another force in the same direction. That's B. What will be the total force on the ball? That will be just A plus B, right? The total force on the ball will be just A plus B, right? Vector A plus vector B. That will be just A plus B. Okay? How could you find that? Because they are acting in the same direction. That's why. If they are acting in the same direction, you can have that idea. You can have that result. Okay. What if they are acting in opposite direction? This is A. A is acting like this, and B is another vector. It is acting in opposite direction. What will be the total force that is on this A? Yeah. If A is a little vector, if B is a little vector, if B is a smaller vector, what will be the combined force that is acting on this ball? That will be A minus B, right? That will be A minus B, and that A minus B will be in the direction of A, because A is the bigger one. A is the larger one. So A minus B will be, and A minus B will not have the length of A. A minus B will not have the length of A, right? It will not have the length of B also. It will be having a length A minus B. It will be having a length A minus B. So that will be vector A minus vector B. Vector A minus vector B. You don't have to write it. I am just showing this to make you understand. Okay. If you writing it, no problem in it. No problem in it. And we can understand this idea, right? But there is a problem. These are vectors. Vectors is having a direction. It can be acted like this, equal direction or opposite direction. It is okay. But what if they are acting in an angle? What if they are acting in an angle? Right? What if they are acting in an angle? A is acting like this. A is acting like this. And what if B is acting like this? If B is acting like this, can you add A and B and just write A plus B? No, you cannot. Can you add A plus minus B? No, that will not be correct. Because they are vectors, they are having a definite direction. They are having a definite direction. You cannot simply add them if they are acting at an angle. So you need laws of vector addition. That's the use of laws of vector addition. Okay? We have to study 3 of them. How many of you have learned from school? Triangle law of vector addition, parallelogram law of vector addition, polygon law of vector addition. Did you study that? Polygon, triangle law of vector addition, you studied that. What about parallelogram law of vector addition? Huh? That may be, but not polygon law. Yeah, triangle law. Then laws of vector addition. What is the use of laws of vector addition? Don't write it now. I will explain that. To find what? To find resultant. That can be a force, that can be a velocity, that can be an acceleration, that can be a momentum, that can be any vector. That's not force always. Force is the simplest thing we can understand. That's why I choose force. Okay. So to find the resultant can be represented like this. Resultant R with an arrow is a vector. Resultant will be a vector. Okay. And you have a triangle law of vector addition. Triangle law of vector addition. Triangle law of vector addition. Huh? And you have another one, parallelogram law of vector addition. Parallelogram law of vector addition. Okay, parallelogram law. And there is third one, polygonal law. Okay, law of polygon. Polygon law of vector addition. Should I write it? Polygon law of vector addition. Have they taught you in the school? Polygon law. I'll write it. I'll show it. You don't have to
No,
study.
sir. They
Okay.
did not teach us.
Have you studied that in school, Jaden?
No.
Yes,
No.
we learned the
No.
parallel triangle. We also learned polygon.
I didn't get it, Jaden.
No, we learned we learned triangle and parallelogram as well. Polygon as well.
Both
Polygon.
of them only.
No. Polygon as well.
Polygon. Okay. Okay, then polygon. Polygon law of vector addition. These are very simple. These are very simple to understand, actually. I will show that. Okay. First, triangle law. Triangle law of vector addition. Triangle law of vector addition. Very simple. Let me show you. Let me show you. I'm taking 2 vectors. Okay, I'm taking 2 vectors. The first vector is this. I'm calling it as A. Now, I have another vector like this. I'm taking it as B. I have another vector, I'm taking it as B. Now B is like this. This is B. And what is the specialty of A and B? They are acting at an angle. They are not in the same direction. They are not in the opposite direction. They are acting at an angle. A and B are acting at an angle now. A is like this, B is like this. So there is an angle between them. So you cannot simply add them or subtract them to find the resultant. So what you need to do? You need to apply this triangle law of vector addition. Triangle law of vector addition. I will show you triangle law of vector addition. I will show you triangle law of vector addition. Okay? What is triangle law of vector addition? If I have two vectors like this, I can represent those two vectors as two adjacent sides of a triangle. Two sides of a triangle. Two sides of a triangle taken in order. Two sides of a triangle taken in order. Now this A and B are two sides of a triangle in an order. What is that order? Tail, head, tail, head. This is now in an order. Okay? Okay? And their resultant will be the third side of the triangle, but in reverse order. Their resultant will be the third side of the triangle, but in reverse order. What is the third side of the triangle? The third side of the triangle is this one. Okay? If it is in same order, tail, head, tail, head, tail, head. If it is in same order, it will be like this. Right? It will be like this if this is in same order. This will not give you resultant. This line will not represent resultant. What is resultant? Resultant should be in reverse order. Now this vector is representing resultant of A and B. This vector is representing resultant of A and B. What is the physical meaning of this? That may be confusing. If you are studying this, that may be confusing. Let's imagine this as force. I am pushing this ball in this direction. That's A. A is a force. A is a force. I can represent force as a vector. So I am pushing this ball in this direction, the direction of A. And Namira is coming towards this ball, and Namira is pushing this ball in direction of B. Right? Namira is pushing the ball like this. This is what? This is direction of B. Did you see it? Namira is pushing the ball like this. I am pushing the ball like this. Namira is pushing the ball like this. What will be the direction of ball? What will be the direction of ball? Ball will go towards my direction. It will go towards Namira's direction. No. It will go towards this direction. That's the result. That is the result. Did you get it? That is the result. And how much force will be on that board? This much force will be on that board. I am giving this much force. I am giving A. Namira is giving this much force. Namira is giving B. So the force on the ball will be this R. Force on this ball will be this R. You got it? That's triangle law of vector addition. So what is triangle law of vector addition? If you represent two vectors as two sides of a triangle taken in order, their resultant will be represented by the third side of the triangle taken in reverse order. Did you understand that? You don't want to study that. Did you understand that? Did you understand what is happening here? Then convert that into words. That is law of triangle of vector addition. Triangle law of vector addition. Did you get it? I will explain it. I will state it once again. If you have two vectors, that two vectors can be represented as two sides of a triangle taken in order. Then their resultant will be the third side of the triangle taken in reverse order. Yeah. Then their resultant will be the third side of the triangle. Now this is a triangle, right? Third side of the triangle taken in reverse order. Did you get it? So you can write it. I will tell you what to write. Addition of vectors, you have written it, right? Did we write for resultant? Note of resultant? Okay. Then write laws of vector addition. Our subheading, laws of vector addition. Laws of vector addition. Laws of vector addition. To find the resultant of vectors acting at an angle. That is the use of. To find the resultant of vectors acting at an angle. to find the resultant of vectors acting at an angle. To find the resultant of vectors acting at an angle. To find the resultant of vectors acting at an angle. Got it? Then write triangle law of vector addition, parallelogram law, polygon law. Triangle law of vector addition, parallelogram law of vector addition, polygon law of vector addition. Yeah? Three of them. First triangle law, then parallelogram law, third polygon law. Now write triangle law. Now write triangle law of vector addition. Just write triangle law. That will be the triangle law and draw this. After writing triangle law, just draw this figure. Okay? After writing triangle law, draw this figure. Draw this figure. Can I state that? I haven't changed the direction of B, right? I haven't changed the direction of B, but I consider this A and B as free vectors. We cannot do this with the position vector, right? We can do this operation only with the free vectors, without any fixed initial point. Okay. So right, if two vectors are represented by, if two vectors are represented by two sides of a triangle, taken in order, two sides of a triangle taken in order, their resultant is represented by the third side of the triangle, taken in reverse order. Third side of the triangle taken in reverse order. Third side of the triangle taken in reverse order. Taken in reverse order. Did you get it? Okay. Then I'll be moving with this second one. That's parallelogram law. Parallelogram law of vector addition. Parallelogram law of vector addition. Okay? Okay, I will show you what is parallelogram law of vector addition. This is vector A. This is what? This is vector A. This is vector. Now I will show you vector B. Vector B is like this. This is vector A. And this is vector B. Okay? Now, what is parallelogram law of vector addition? What is a parallelogram? What is a parallelogram? This is a parallelogram. This is a parallelogram. What is the speciality of a parallelogram? Their opposite sides will be parallel. Their opposite sides will be equal and parallel. They will be equal and parallel. This is a parallelogram. That's basically a rectangle. That's basically a rectangle. And their opposite sides will be parallel. Got it? Okay. So that's a parallelogram. That's a parallelogram. Now, what is this parallelogram law of vector addition? Let's see. I'm taking this first vector. Okay, I'm taking this first vector. I'm placing it here. This is a free vector. I can place that anywhere as I like. And I'm taking this second vector. I'm placing it at the same point. Like it is starting from the same point. Like it is starting from the same point. Right? This starting from the same point. At first, in the case of triangle law, I placed the vector on the top, on the head of A. I placed the vector B on head of A for triangle law. For parallelogram law, Now I am placing the vector on tail of A. Tail and tail are joined together. Tail and tail are joined together for parallelogram law. Got it? And what is this? Now this is two sides of a parallelogram. Now this is two sides of a parallelogram drawn from this point O. Okay? And I can complete the parallelogram just like this. Draw a parallel line here and another parallel line here. Parallel line which is parallel to B. I know has a parallelogram. I know has a parallelogram, right? Then what will be the diagonal of these two vectors? What will be the diagonal of these two vectors? The diagonal of these two vectors will be diagonal of these two vectors will be the resultant. From the same point, that only could be resultant. There is another diagonal. You can show another diagonal here. This is also another diagonal. This is also a diagonal, but that diagonal is not resultant. Why? Means I can show you why. Because this is a parallelogram, right? Okay. In that parallelogram, there is actually triangle law of vector addition embedded in it, hidden in it. Huh? What is this? This is B. If this is B, this is also B. Right? Then this is what? This is A. This is B. So what will be the resultant? Yeah, the resultant will be from this point to this point. That's it. Okay? And this diagonal cannot be result. This is the result. How can I state that? How can I state that? If two vectors are represented, two adjacent sides of a parallelogram drawn from a point, their resultant will be the diagonal of the parallelogram drawn from the same point. Their resultant will be the diagonal of the parallelogram drawn from the same point. Got it? I will tell you. I will give you the note. Right? Parallelogram law of vector addition or parallelogram law will be enough. Parallelogram law. Okay, Gautam, got it. If two vectors are represented by, if two vectors are represented by two adjacent sides of a parallelogram, two adjacent sides of a parallelogram, if two vectors are represented by two adjacent sides of a parallelogram, two adjacent sides of a parallelogram drawn from a point, drawn from a point, their resultant is represented by the diagonal of the parallelogram. Their resultant is represented by the diagonal of the parallelogram drawn from the same point. Drawn from the same point. Their resultant is represented by the diagonal of the parallelogram drawn from the same point. Diagonal of the parallelogram drawn from the same point. Did you get it? Okay. Now that's parallelogram law of vector addition. Now I will show you polygon law. If your school hasn't taught you that, you don't have to study that. Okay? In some schools, they have taught you, taught the students that. That's pretty simple actually. I'll show you what it is. I'll write it here. That's polygon law. Polygon law. Polygon law means more than three sides. That's polygon law. More than 3 sides, that's polygon law. If you have more than 3 vectors, sorry, more than 2 vectors. This is first vector. Okay, this is second vector. Okay, this is third vector. Okay, this is fourth vector, and this is that four vectors. If you have 4 vectors like this is vector A, this is vector B, this is vector C, this is vector D. If you have 4 vectors like this, you can build a polygon from this. You can build a polygon from this. What will be a polygon? A shape which has more than 3 sides. A shape in which more than 3 sides. That's I am taking this A. I am taking this A. I am placing A here. Right? I can do that, right? It's a free vector. And I am taking this B. And I am taking this B. And I am taking this B and I am placing B here. I can do that, right? Okay, then I am taking this C and I am placing C on top of B like this. And for the last, I am taking D. I am taking D. I am taking D. And I am placing D at the top of C. Now this is what? This is a polygon. This is a polygon. Polygon means having sides more than 3. Triangle. Yeah, it's a polygon if I am closing it like this. Okay, then what will be the resultant? These are the vectors. So, what will be the resultant? Resultant will be the closing side of the polygon in reverse order. Resultant will be the closing side of the polygon in reverse order. Now this is the resultant. Resultant will be the closing side of the polygon in reverse order. Got it? They are in same order. A, B, C, D are in same order, but resultant is in reverse order. That's polygon law. You can write if you want. Polygon law of vector addition. Polygon law. That's actually simple, right? Polygon law. Polygon law. If a number of vectors are represented, by the sides of a polygon, taken in order, their resultant is represented by the closing side of the polygon. Their resultant is represented by the closing side of the polygon. Taken in reverse order. You can draw the figure. Taken in reverse order, you can draw the figure. Okay? Taken in reverse order, you can draw the figure. Okay? Tell me if you have finished. We will wind up the class with a derivation. This will be our last topic to discuss. It's a simple derivation. Okay? Now, this is the graphical method of vector addition. What is this? This is the graphical method of vector addition. Graphical method means you need figures for this. You need to show the figures for this. But that's not practically possible every time. It's not practically possible every time. If you have to find the resultant for every time you are taking a scale and pencil, that's not practically possible, right? So there is an analytical method of vector addition. There is an analytical method. Analytical method of vector addition. Analytical method of vector addition. There is an analytical method of vector addition. Let's see what is this analytical method of vector addition. Analytical method of vector addition. You can write with me. You can write with me. Let's see. I am taking two vectors like this. This is my first vector, right? This is my first vector. Okay? And I have drawn that vector from O. I have drawn that vector from O. And this is my point P. This is my point. I will take the points that is in the node. This is my point P. This is vector A. Okay. Now I am taking another vector in this direction. Which is this? Which is this vector? This vector is B. What is this vector? This vector is B. This vector is B. This vector is B. And it is like this. Now this is two sides of a parallelogram. Now this is two sides of a parallelogram. Now I can complete this parallelogram. I can complete this parallelogram like this. If I am drawing a parallel line, it will be like this. It will be going on like this. And if I am drawing another parallel line, which is parallel to vector B, it will be like this. Now this is a parallelogram. This is a parallelogram. What will be the resultant of the parallelogram? Resultant of these two vectors. The resultant of these two vectors will be the diagonal drawn from the same point. The resultant of these two vectors, vector A and vector B, will be the diagonal drawn from the same point. That's all. Okay? And this is P. I am taking this point as Q. I am taking this point as Q. This is what? This is the resultant. This is the resultant. Okay? Now I have to find the magnitude of resultant and direction of resultant. I have to find the magnitude of resultant and direction of resultant. For that, I need two angles. I need two angles. I am taking the first angle here. I am taking the angle between A and B as theta. So what is theta? Theta is the angle between A and B. Vector A and vector B. Theta is the angle between A and B. I am pushing like this. Namira is pushing like this. So this is my force. This is Namira's force. There is an angle between them. Right? There is an angle between them. That's theta. Got it? So that's theta. And I need another angle. Another angle. This is the angle alpha. What is this angle? Alpha. Alpha is a symbol. Greek alphabet actually. Alpha. Alpha is the angle between what? Alpha is the angle between resultant and horizontal. Resultant and horizontal. Resultant and horizontal. Resultant and horizontal. You got it? Resultant and horizontal. And I need some more points. I need some more points. I am taking this point as S. I am taking this point as S. Okay? For C. I am taking this point as C. Is that okay? C. Okay. Then I am completing. I am extending this line like this. I am extending this line like this. Okay? And I am extending the point like this. And extending the point like this and like this. Okay. Then I'm taking this point as D. So A, B, C, D. This is not repeating. That's why I took it as D. Okay. And if this is B, this also will be B, right? Because of the identities of parallelogram, opposite sides will be equal and parallel. So if this is B, this also will be B. Right? And if this is theta, this also will be theta. Got it? If this is theta, this also will be theta. This is the horizontal line, this is the parallel line. This is the horizontal line, this is the parallel line. So this is theta, this is theta. Okay. Now I want to find an equation for resultant. I want to find an equation for resultant. How can I find the equation for resultant? How can I find the equation for resultant? What is this resultant actually? This resultant is actually ODC is a triangle, a right angle triangle. Huh? Hypotenuse of that right angle triangle is this. Okay. So I can choose this triangle from right angle triangle, the bigger triangle, ODC. ODC. I can write from the triangle ODC. Can you see that triangle ODC? Okay. From triangle ODC, use Pythagoras theorem. What is Pythagoras theorem? Hypotenuse square will be equal to base square plus vertical square. Right. Then what is hypotenuse? OC. OC square is equal to, which is the base? OD square plus DC square or CD square. CD square. Is that okay? Okay. Now, what is this OC square? What is this OC square? OC square is the resultant. It is the magnitude of the resultant, actually, the length of this R. Okay, so OC square is actually R square. I can take it as R square. Now, what is this OD? The OD is OP plus PD. Right? It is OP plus PD, the whole square, plus CD square. CD square is there. Okay. Now this is A plus B whole square. What is A plus B whole square? A square plus 2AB plus B square. So you can write it A square plus 2A into B plus B square plus CD square is there. Right? Now look here. Now look here. Who is this PD square plus CD square? Who is this PD square plus CD square? PD square plus CD square will be hypotenuse square PC square. Right? There is another triangle PDC. There is another triangle PDC. From triangle PDC, what is this PD square plus CD square? PD square plus CD square will be PC square. So this will be what? This will be PC square. You can substitute that. Did you understand why this is PC square? Amira? That's PC square. This is base, this is vertical. So base square plus vertical square will give you hypotenuse square. Okay? Then that's PC square. Now I have an equation. What is this? R square. Right? R square. So R square is equal to, what is this OP? OP is A.
Yeah.
OP is A. So A square plus 2 into OP, 2 into A, 2 into A into PD. What is this PD? You don't know. Don't know PD. You don't know PD. So you can write it as PD. 2 into PD plus 2 into A into PD plus, what is that? That's PC square. That's PC square. PC square. Now what is PC square? Yes. PC is what? PC is B.
Huh?
PC is B. OQ is B. PC is also B. So that's what R square is equal to A square plus 2 into A into PD plus B square. That's not D, that's B square. PC square. That's B square. Now there is a slight little problem. What is that? There is a PD. There is a PD. We don't know what is PD. We don't know what is PD. You have to find PD. How can you find PD? PD is a side of this triangle. Yes. You can use Pythagoras theorem from this triangle, triangle PDC. From triangle PDC. From triangle PDC. From triangle PDC. From triangle PDC, what is PC square? Sorry, PD. What is PD? How can you find PD? That's the adjacent side of theta. That's the adjacent side of theta. So you can use this equation cos theta. What will be cos theta? You have to remember the identities of trigonometric identities of a triangle. Sin theta, cos theta, and tan. What is sin theta? Sin theta will be opposite side by hypotenuse. What is cos theta? Adjacent side by hypotenuse. That's cos theta. Right? So theta has an adjacent side PD. We need PD. So you can take cos theta. Got it? So cos theta is equal to adjacent side divided by hypotenuse. Who is hypotenuse here? PC. Now you can find PD. PD is what? PC into cos theta, right? You can bring this PC to the other side. You can find PD by just letting this PD there, stay there, and bring this PC to the other side. Then PC into cos theta. PC into cos theta. Now tell me what is PD? What is PD? What is the equation of PD? PC into cos theta. What is PC? PC is B. PC is B. So B cos theta. That's what? B cos theta. So you got PD now. You got PD now. That's the end of it. R square is equal to A square plus 2A into PD. What is PD? B cos theta plus B square. Read it. What is that? R square is equal to A square plus 2AB cos theta plus B square. This is R square. This is R square. If you need R, what will be that? This is square root of, this is R square. So square root of A square plus 2AB cos theta plus B square. That's the magnitude. Or you can read it like this: root of A square plus B square plus 2AB cos theta. That's enough. That will be okay too. No, our time is 8:45. I have notified it as 8:35. Sorry, 8:45. Do you have anything important? Just complete. We will just complete this and we can go. Okay? No. This is only magnitude. We have to find the direction also. That's very simple. That's very simple. Direction part is very simple. This is magnitude part. This is magnitude part. This is what? This is magnitude. Please stay with me. This is magnitude. Okay? Now you need direction. Now you need direction. What is direction? If you find this alpha, you will get direction. If you find alpha, you will get direction. So you can find direction like this. Can I move to the next page? Is this complete? I will show you direction here. Direction. If you need a direction, you can find this tan alpha. What will be tan alpha? From which triangle? Alpha is an angle of which triangle?
ODC.
Yeah, triangle ODC. From triangle ODC. From triangle ODC, you can have tan alpha. What is that? Tan alpha from triangle ODC. Yeah, opposite side by adjacent side. We didn't get tan from anywhere. Tan is an identity to this triangle. Okay?
How do we go to that?
Because we need this alpha. We need this alpha. Okay? You can use sine alpha to find alpha. But there is a problem. What is that problem? That's opposite side by hypotenuse. Hypotenuse is okay, but the opposite side is not okay. Why? The opposite side cannot be in an equation because I am the one who put that opposite side there. That should not be in an equation. I put that opposite side for my convenience. So that should not be in an equation. That's why I am taking the tan. Okay? So if I am taking tan alpha, what will be that? Opposite side divided by adjacent side. I can remove that idea from another thing. Just look at it. What is that? What is that? Opposite side divided by adjacent side. Which is the adjacent side? That's OD. That's OD. That's OD. Huh? That's OD. Now, what is tan alpha? CD by OD. We know OD, right? CD divided by OD is what? OP plus PD, right? OP plus PD. OP plus PD. Okay? OP plus PD. And we know OP and we know PD, but we don't know CD. We don't know CD. How can you find this CD? What is CD? What is CD? CD is a part of the next triangle, the smaller triangle. CD is the part of the smaller triangle. CD is the part of the smaller triangle. So you can find this CD from the smaller triangle just like that. Yes, Pythagoras theorem. You can use Pythagoras theorem. And from which triangle? From which triangle? PDC. From which triangle? From triangle PDC. From triangle PDC. From triangle PDC. From triangle PDC. Which side you need to find? Opposite side. In which identity, in equation of which identity you have opposite side? That's sine. That's why I can use sine. That's sine theta. Sine theta is opposite side by hypotenuse. What is opposite side?
CD.
Yeah, CD is the opposite side of theta. Yeah, CD by PC. Okay. So sine theta will be CD by PC. CD by PC. Now CD. What is CD? PC into sine theta. You can bring this PC to the other side. PC into sine theta. CD. If you want to find CD, you can bring this PC to the other side. That will be PC into sine theta. And CD is what? PC. Who is PC?
B.
PC is B. So B sine theta. B sine theta. Now you know what is CD and you can write the equation of tan alpha now. What is equation of tan alpha? Tan alpha is equal to CD. What is CD? CD is B sine theta divided by OP.
Plus OD.
No, OP plus PD.
Oh,
Who is OP? A. A plus,
2 cos theta.
no, PD is what? PD, PD.
Yeah,
B cos
two
theta.
cos theta. B cos theta.
B cos theta. PD is what? B cos theta. B cos theta. This is the equation for tan alpha, and you can find alpha from this. That will be, you can take tan inverse of this thing. If you want alpha, you can take tan inverse of this thing. Tan inverse of B sine theta divided by A plus B cos theta. This is the equation for direction. This is the equation for direction. Direction is the one represented with alpha. So alpha is equal to tan inverse of B sine theta by A plus B cos theta. Yeah, this derivation can be asked.
This is magnitude, the
So we
Yeah.
have.
There will be questions coming from,
the other one, magnitude.
yeah, there may be questions coming from this part. But that's actually simple. R is equal to root of a square plus b square plus 2ab cos theta. If you study that by heart, you can use that equation to find the circle. You didn't inform him that class is at a perfect. Then take the form. Take the form. Yes.
The correct.
Okay. Is it okay? Is it complete? Did you understand that? Everyone? Did you take the note? That will be. Yeah. The real life example, we just stated that.
Like a difference between this. Example.
No difference in it. You can use triangle law to find the resultant, or you can use parallelogram law to find the resultant. They are basically same. You can use triangle method, well as triangle method to find the resultant.
No, case that.
No, that will not be asked for numericals. They will just be asked for conceptual questions. You can just state them. And we have used the parallelogram law in this case to derive the equation. We use the parallelogram law. There's actually no difference between them. Both of the laws are graphical methods and they are used to find the resultant by graphical method. Both of them are just graphical methods. You will not use them in a numerical question. You will use this equation in numerical questions. This equation is pretty simple. If you have two vectors and the angle between those vectors, you can find the resultant. You don't need to draw a triangle. You don't need to draw a parallelogram. That's the beauty of it. That's the beauty of this equation. You don't need to draw parallelograms. You don't need to draw triangle. You don't need to draw polygon. You can just use this equation. Yeah. This is diagonal. Okay, guys. See you later. See you in the next session. See you later. I will try to arrange an extra session to do the numericals. Okay. See you later. Bye. Thank you all. Gautam, Jaden, Joshua, Sneha. Did you take this
Thank you,
note?
sir.
All of you? Have you taken this note?
Yes, sir.
Have you completed this note?
Yeah, finished.
If you have completed the note, you can leave the session.
Okay, bye,
If you
sir.
have completed the note, you can leave the session. Bye all. Is there any doubt regarding it? Okay. Bye. Thank you.